Hey everybody, in this video we are going to work on the workbook from the topic that we just covered, which was the associative, commutative, and distributive laws. And first we are going to talk about like terms and combining them, and we're going to practice it. And then we've got several pages of practicing and working on the associative, commutative, and distributive properties. Sometimes they're called laws, sometimes they're called properties. You can use either term. So what I'm going to do, I'm actually just going to do several problems on each of the pages. And then, at some point in time, if you're like, okay, I got it, I don't need any more examples, you don't have to watch all of these examples. This is just to help you because this is part of your homework, is finishing up the rest of the problems on these workbook pages. So let's check out the directions. It says simplify the following expressions. Some may not contain any like terms, so you'll just rewrite the problem statement. So we are just to simplify. So we're just going to start with number one, and we look at the first one and we say, okay, 18x plus 18y. Do I have any like terms? The answer to that is no, because it's an x and it's a y. And though the coefficients are the same, that doesn't matter. They have to have the like terms in order to combine them. So we just rewrite it. 18x plus 18y, and that is our final answer. I would also like to do number 3 with you. So we're going to jump down here to number 3. And we're looking at this one. Again, I'm looking in here, seeing if I can combine anything. I cannot. So then I'm going to use the distributive property. I'm going to distribute that negative into parentheses. And again, you can kind of think about it in terms of it being like a -1 here, if you'd like. And so when I distribute, I'm going to have 4w squared minus 3, because it's going to be -1 times a positive 3. And then a -1 times a positive w squared is going to be minus w squared. So now I look at that expression and I see what can I combine, and let's put our answer in alpha descending order. So we're going to have the 4w squared and the -w squared. So 4w squared minus 1w squared is going to give me 3w squared. And then finally, I've got this -3 by itself. And that's your final answer for that one. We are going to jump up to number 6. And number 6, let's look at each of these and say, do any of them need to be rearranged? The first and the third terms look good. The second one looks like we could change it to write 3cd plus cd. Again, what property is that? They trade places across multiplication. That's the commutative property of multiplication, plus c squared. So when we combine these, 3 and 1, that's going to give us 4cd, and then we've got c squared. But before we do that, I want to think about my terms and put it in alpha descending order. Alphabetically, which one would come first? It should be the c squared by itself. So c squared, and then 3 and 1 is going to give me 4cd. And again, the reason why I put the c squared first is because we're going back to just the conventions that we were talking about putting it in alpha descending order. Next, what I would like to do is check out number 11. Number 11. So first, what I would like for you to do is look at what happens in here. So combine any like terms that you see. So see what you're getting. I'm going to rewrite the -s to the 5th out here. You got 2 and 3s, 2s and 3s. That's going to give us 5. Sorry, my 5s and s's look very similar. You end up getting 5s minus 5s. Well, how many s's are we left with then? 0. So then we get -s to the 5th times 0. Any number times 0 is going to give us what? 0. Big fat goose egg. 0. So that's your final answer for that one. Then for number 12. Number 12, again, look at your problem and say, are there any like terms to combine? And I do. I see t to the 4th here and t to the 4th. So let's look. And we're given 2 fractions. So in order to combine fractions, add or subtract them, we have to get what? We have to get a common denominator. So let's get a common denominator. And I'm going to say it's 21 because 7 times 3 is 21. So I'm going to do times 7 times 7. That's going to give us 49. T to the 4th. I've got a subtraction sign I have to squeeze in here. And I'm going to do times 3 times 3. That gives us 9 over 21 t to the 4th minus 3/7 t. All right, now let's combine. We've got, again, we've got our common factors, or like terms is actually what I was trying to say. And let's go ahead and take 49 minus 9. That gives us 40 over 21. That kind of looks like a weird one, so I'm going to rewrite that. Over 21, t to the 4th minus 3/7 t. And that's your final answer. That's as far as we can go. And if you change this into a mixed number instead, that's also fine. You can rewrite that as a mixed number. So your task is to finish the rest of the problems on this one, including number 13. So go ahead and finish the rest of them on this page. And then if you would like to, you can pause the video and you could go ahead and finish this one and then restart the video. And then what's happening here? Then you can restart the video and I'll do some more on this side. So pause the video, finish that other one. And now let's do some problems on the back page. All right, we're going to start with 15. So number 15, and let me read the directions to you first. It says, simplify the following expressions and write them in standard form, meaning alpha descending order. Some may already be in standard form and or not contain any like terms, so you'll just rewrite the problem statement. You may assume that no variable is 0. Why that's helpful, like why this piece is in there, because like let's say these were 0. If like x's were 0, this would be 0 plus 0 plus 0. So that's why that statement's in there. So we can say, we can assume that nothing is 0. The other problem that we would run into is if we ever had a 0, I'm trying to see if we see one. If there was a variable in the denominator, that's another problem. That would be another issue. Also right here. Anyway, there's other issues. You guys don't have to worry about it. Not right now. I'm just telling you why that's in there. Okay, let's do 15. So first look at each of the terms and see if you need to reorder any of them. I'm looking at these two. So why don't you go ahead and rewrite those two? I'm going to do that as well. So we're going to have 4ab plus 3cd minus ab. That's the commutative property of multiplication, right? Plus ac. Again, commutative property of multiplication. Now look across. Do we have any like terms? I see an AB and an AB, and I don't see any other like terms. The next thing I want you to think about is sorting them into categories about which one would come first, which one alphabetically and in descending order would come first. Would it be the AB terms? Would it be the CD terms or the AC terms? And I'm hoping you're saying the AB terms. So 4AB minus AB is going to give us 3AB, and that gets rid of those. The next one alphabetically would be this one with the A in it. So I'm going to write plus AC. And then the last one is going to be this one by itself. So we've got plus 3CD. And that's as far as we can take it. We can't combine anything more. So that is your final answer for that one. Okay, let's check out number 19. Because this might be a rule you haven't used in a while. So we've got 6z to the 0 power minus 4. This is one of those things that you may not remember, and that's okay. We're going to cover it in a few more sections, but here's an exponent rule. And when you have any non-zero number raised to the 0 power, it's like if we had 5 to the 0, what would that equal? It equals 1. That's one of your exponent rules. If you don't understand why right now, I don't want you to worry about it. We are going to cover it in some future sections. Right now, I want you to believe me that z to the 0 is just going to equal 1. So what that means is we get to go 6 times 1 minus 4. And then we get 6 times 1, which is 6 minus 4 gives us 2. And that's your final answer for that one. Let's check out number 21. Let's try 21. So 21, again, it's similar to the one with a fraction on the previous page. We're looking for any like terms, and I see like terms here of g squared. And then this g to the first, I'm just going to rewrite it as plus 7g when I get there. But what that means is I need to get a common denominator in order to subtract those fractions. And our common denominator, oh, excuse me, is going to be 12. It's going to be 12. So let's multiply this by 4 and the numerator by 4. So that's going to be 4 12ths g squared minus, and then to get a 12 here, we're going to multiply this by 3 and then this by 3. So that's going to give me 9 12ths g squared. That's a 9. My pin slipped. Plus 7g. So now let's go ahead and combine. And we've got 4 minus 9 is going to give us negative 5. So it's going to be negative 5 12ths g squared plus 7g. And that is going to be your final answer. So that's it for that one. So that's all I'm going to do for you on this page. So your task will be to finish the rest of the problems on that page. So if you want, pause the video again, because then we're going to flip to the next page. We're going to be working on the next 3 pages of 97. Well, I don't know if it'll be 97 in yours because sometimes the page numbers change. But for the copy that I have, we are going to be looking at this page, which for me, it's 97. If it's not 97, it'll be close to 97 on yours. We're going to check out this page, and then we're going to finish up with this page. So I'm going to do some examples on all 3. All right. So associative, commutative, and distributive laws. So the first direction here, or the directions that are given, say, identify whether the property used to rearrange the expression was the associative, commutative, or distributive property. If it was the associative or commutative property, determine whether it was of multiplication or addition. Then circle the letter in the appropriate column next to the equation. Finally, write the letters out to answer the riddle. So the riddle is going to be down here. So that's honestly a great way to check your work. If you get an answer down here and it's spelled weird or it doesn't make sense, then that means you did something wrong up above. So this is going to be how you're going to check your work, is to make sure that this statement down here makes sense, because it should answer this really ridiculous, corny joke. Why did the Romans find algebra so easy? And I know that this is going to be so funny, that this is going to be a joke that you remember and you're going to take with you in the future and tell it to your own students one day, or tell to your friends. I'm sure that's going to be the case. All right, so here's our task. I'm going to start with number 5 with you. So we're going to look at this one. And what we're looking at is we're looking at the left side over here compared to the right-hand side. And we're seeing, let's just like make some observations. What do we notice happened from the left side to the right side? So I want you to think about that. Like, what do you see as different, the same? So something I see is that the order of the terms from the left side to the right side are in the exact same spot. So I take my pencil and I go 5A, 2, 4. Let me look over here. 5A, 2, 4. What property is it that keeps them in the same order, but what did change? The parentheses. The parentheses moved. First, they're around the 5A and the 2. Well, we can't combine those. So we moved it around the 2 and the 4 because we can combine those. What property is it that moves the parentheses? I'm hoping you're thinking associative property, right? We associate with groups. So it's associative property. Well, how do we decide? Is it of addition or is it of multiplication? Because that's what we have to decide now. Well, did it move across addition or did it move across multiplication? And it changed position across addition. So we've got addition, addition, and so it moved places across addition. So the answer is that we have associative of addition for that one. So then what that means is that number 5, let me write it down here. Number 5, we are going to write in, what letter was that? U. So we write in a U. All right, which one am I going to do now? I'm going to do 6. I'm going to look at 6. I'm going to get rid of my other markings here so I have more space. Number 6. So we've got 6b plus 2 plus 7 equals 2 plus 6b plus 7. We'll check. Are they in the exact same order? 6b, 2, 7. Nope. 6b and 2 change places. but the 7's still in the same spot. Did the parentheses move? No, the parentheses are still around the first two terms, and they're still around the first two terms in the second one. Well, what happened? These two traded places. They traded places across an addition sign. Which property has it that you change places, commutative, across addition, commutative of addition? So it's going to be this one, commutative of addition. I'm going to show you something. If it was commutative of multiplication, this is how it could have looked different. So I'm going to show you, like, let's say we started with this, and I'm going to instead show you something of commutative of multiplication. Instead, what you would look like would be this. We would have B6 plus 2 plus 7. So what that would look like is that everything stays the same, but the 6 and the B traded places, which is, again, commutative of multiplication because they traded places across that multiplication sign, which is how that could be different. All right, then don't forget, go down to the answer and fill in your S above the number 6 blank. All right, now I'm going to do number 8 with you. So we're going to look at 8. 8, it has 440D. 440D. All right, something happened. They're not in the same order. They changed places, and I'm hoping you're seeing they changed places. It's a cross multiplication. So that's commutative of multiplication because they traded places across that multiplication. We're going to look at number 10. Number 10. What do you see happen? So I would just look with your eyes from left to right across the equation. What happened? I'm hoping you're seeing that the parentheses kind of changed. And then we've got a -3 in both the first term here and the second term. What property does that look like? I'm hoping you're saying distributive because that's exactly what it is, because it would be distributing here and we're distributing there. By the way, that's how you can kind of show your work, is draw your arrows for what's happening. And we're going to mark distributive on that one. So, oh, did I get off? I got off on that one. Need a ruler. All right. So you need to go mark an A where the blank for number 10 is. Then I'm going to look at number 13 with you. Let's look at number 13. That's going to be my last one for this page. So number 13, looking from left to right, we've got 3, 4, 5K. 3, 4, 5K. Exact same order. What changed? The parentheses. So that's what we're going to do. That's how you're going to show your work. You're going to say the parentheses moved this direction because that's what they did. They used to be here and now they're going around the 4 and the 5. That's the associative property. What operation did they move across? Multiplication. So we're going to say associative of multiplication. Let me make sure right there. So make sure down below you are putting an L above the number 13, blank. Okay, your job is to show your work on the rest of these, like just the little arrows to show you, like, are we distributing? Are we commuting? Are we doing the parentheses and they're moving that way or they're moving this way? That's how you can show your work on those. And then we're gonna look at the next page, which is a little bit trickier. It says, identify which properties were used to rearrange the expressions and in what order. If the properties could be applied in either order, choose either order. Where am I at? Then circle the letter in the appropriate column next to the equation. Finally, write the letters out to answer the riddle. So this riddle is, why shouldn't you leave ice cream in the corner of the room? It's another good one. So if it doesn't make sense down below, or if it looks like you misspelled something, go back and check, because that means you made a mistake. So let me talk about the order part. If you notice in our labels up here, there's no distributive property. So you don't have to worry about distributive. What we're really focusing on this page is associative, commutative. So associative are the parentheses moving. Commutative are terms changing places, changing the order. And sometimes it matters which one comes first. So the associative means, like if we're looking at this one, associative means that the parentheses had to move first and then the terms moved places. Like that. Whereas this one right here, I'm gonna change pens. This one, the commutative and then associative, means that the terms changed. So terms moved. And then the parentheses changed. So I'm trying to think of an example here. Let me think. So a commutative and then associative. Let me see about like this. A plus B plus C. So let me show you one where it's this example. Commutative and then associative. So let's say we commute and we go like that. And so then we would have B plus A plus C. And so this would be commutative of addition that's taking place. So I'm just writing the property in between my steps. And then I'm going to do the associative property of addition, and I am going to move my parentheses to the right. So then that means that my answer is going to be B plus A plus C. And in that order, what that means is that I had to do the commutative property first, followed by the associative property. Well, what if we switched it? Let's see if I do it the reverse order. If I do associative and then commutative, if I end up with the same answer or not. Sometimes you do and sometimes you don't. So I'm going to start with what I started with, which was A plus B plus C. This time though, I'm going to do associative and then commutative. So I'm going to do associative, which means my parentheses are going to go this way. This is the associative addition property. And I'm going to do A plus B plus C. So that's what it'll look like because my parentheses are moving. And then now I'm going to do the commutative property. And you can do commutative this way. And I'm going to show you one other way to do commutative as well, because you're going to see it here in just a second. So we could do commutative of addition. And that would mean we're going to end up with A plus C plus B. Now compare our two answers. Here's one, here's the other. Are they the same? No, they're not. So this is an example where you have to pay attention. You have to pay attention over here with what you started with and see how do we get what we ended up with and in what order. And sometimes the order doesn't matter. And I'm going to give you a hint. There are two. There are two that you will find in this column. So hopefully if you're watching the video, that's a big hint that there's only two of those. It can happen in either order. Other than that, they're going to be falling in one of these other four categories. All right, let me show you one other way because this has been confusing for students. I'm going to take this step right here and I'm going to move it down here. So I told you that there's one other way we could do the commutative property. We can also do the commutative property. Instead of doing what's inside parentheses, we take this quantity and we trade places. So we can trade places like that, right? That's crazy. But that's what we're doing. We're taking that entire quantity, we move it to the front. And again, it's still going to be commutative of addition because what's the operation it's moving across? It's moving across that addition sign, right? So we're going to do B plus C plus A. And then that would be your final answer. And then look at any of these. Are any of these the same? No, they are not. This one's starting to get close. The first one and my third option are getting close, but they're not the same. So just showing you how all of the properties can rearrange your terms into lots of different ways. And then I'm going to tell you one thing that breaks the rule. This is something that students try a lot, and it is not allowed for this. Students will try to say, oh, I'm going to do the commutative property and I'm going to trade those two. You cannot do that. That's like ripping C out of its grouping, and you cannot do that. So, I mean, think about how harmful that would be for somebody to just be ripped out of their peer group, ripped out of their grouping. You cannot do that. You have to change the parentheses first and then move things around. So this, taking C and doing like this where you would have, now I'm going to have B plus A plus C. That is not allowed. Don't try to do that. And again, if you want to write yourself a note, you cannot rip or you cannot pull a term out of its parentheses. So don't do that. I'm going to write it up here. Cannot pull a term out of its parentheses. You have to move the parentheses, then move some things around. All right, here we go. Let's do our examples. I'm going to start with 5 down here. And we're going to look at, okay, how did we get from 3 plus 7 plus 9, and now we've got 3 plus 9 plus 7. So when I kind of look at these, I think 3, 7, 9, 3, 7, 9. Okay, so right now I can tell that the 7 and the 9 traded places. That also means, and I also see that the parentheses moved. So you need to think about, well, what happened first? Did the commutative of addition property happen first? Or did the associative of addition property happen first? And sometimes on these, like you're actually going to need to get like a piece of paper possibly. And let me see if I've got this pulled up. Okay. Actually, I don't want to do that. I want to do this. This will be easier. All right, so I'm going to write, like you might need to have out a piece of paper and then do like just a scratch piece of paper and do what I'm getting ready to do. So we have, oh, I looked at the wrong one. All right, that's okay. I'll do number 5 with you. So we had 3, oh my goodness, I'm sorry, you guys. So we have 3 plus the parentheses of 7 plus 9 equals 3 plus 9 plus 7. All right. Let me make this a little bigger. So first, our options again are going to be, we said commutative and associative. So let's try commutative first. So I want you to start with this side, 3 plus 7 plus 9, and we're going to try commutative. So this is commutative of addition. So that means now we're going to have 3 plus 9 plus 7. And then I also see that the parentheses moved. So again, I'm looking at what I have here and how do I get here? And now I'm looking at the fact that here's my step. How do I get from here to my final step over here? And I see that my parentheses need to move, and it's going to go that way. And it's going to be the associative property of addition. And so that means my parentheses are moving, and I'm going to have 3 plus 9 plus 7. And so then on your paper, you are going to need to come over here on number 5, and we did commutative and then associative. So you're going to highlight that U right there. Highlight that U. And then I'm actually going to work up. So I have highlighted 1 through 5, and then we're going to do 19. 1 through 5, and then we're going to do 19. So let's look at 1. So we've got 3 plus 7 plus 9, and then, oh, I don't want that. 3 plus 7 plus 9, and then we're looking at 3 plus 9 plus 7. So looking at the fact, looks like these two traded places, the parentheses stayed the same. So what is that? That should be commutative only. And that was commutative of addition. We didn't ask you to say that, but I'm just writing it in there. We did commutative of addition. All right, so let's look at the next one. This time we've got 3 plus 7 plus 9, and we've got parentheses here. And then we've got 3 plus 7 plus 9. So they're in the same order, but the parentheses changed places. So that means that's the associative only property. And again, that's associative of addition property because it's not moving across multiplication. Now let's look at number 3. Number 3, we've got 3, 7, 9, and this is definitely in the different order, 3, 7, 9. So 9 stays the same. I'm also seeing that the parentheses moved. So 3, 7, and let me go back to my OneNote over here. So our problem was, let me make sure I've got it. We've got 3 plus the parentheses of 7 plus 9, and then equals 7 plus 3 plus 9. So we said associative and commutative property both happened. And so our choices, like, well, was it associative and then commutative, or was it commutative and then associative? And if you don't know, just try it and see what happens. So here's something I look at. I look at the fact that who's grouped together at the end, like who is together, and it's the 3 and the 7. And I see that 3 and 7 are right next to each other here. So that tells me I need to use the associative property first. So I'm going to move this first. And then that's the associative of addition property. So then I'm going to go 3 plus 7 plus 9. And then I'm comparing this to this final one up here. And I see that 3 plus 7 is first, and then over here, 7 plus 3. So I just need to change these two. I'm going to change those two, and then that's the commutative of addition of property. And then I get 7 plus 3 plus 9. Check. I get the same thing I've gotten here to what I was supposed to get for my goal. And so then you need to go highlight, okay, what did we do? We did associative, then commutative. So it was this option. And so what was that? That was letter C. You're highlighting letter C on that one. So let's look at number 4. Number 4 on your paper, we've got, what is it? 3 plus, oh, I gotta make that thicker. 3 plus 7 plus 9 equals 7 plus 9 plus 3. Okay, 3, 7, 9, definitely not. 3, 7, 9. What are you guys seeing might have happened? I'm hoping you might be able to figure this one out. And if not, hang out with me on this video. What I'm hoping you're seeing is that this, the 3 and the quantity of 7 plus 9 definitely traded places right there. So what property is that? That is the commutative of addition property, because it's trading places across that addition sign. So then I get 7 plus 9 plus 3. And then is this what I have over here? Yes, I'm done. So then you need to go highlight, what was it, letter A on that one for the commutative only property. And then I already did number 5 with you. Now we're going to jump down to number 19. Number 19. So number 19, we've got 5 times 4 plus the quantity of 3 plus 2. And that equals 4 times 5, or the quantity of 4 times 5 plus 3 plus 2. All right, so let's look at this and let's maybe make some observations about what we are seeing. So something I'm seeing is that the 3 and the 2 are in the exact same order on both sides of the equal sign. I see that the 5 and the 4 have traded places, and I see that the parentheses have moved this way. So they had been, well, I'm sorry. Well, I guess, yeah. So they've moved that way because they're here. And then we're moving this way and we're including some different numbers. So I'm seeing commutative of multiplication, and I'm also seeing associative of addition. I have no idea what order. So let's try, because it could be either one, associative or commutative. Let's see if we can figure out which way it was. So let's try moving, let's just try doing the parentheses first. So I'm going to start with this. I'm going to move the parentheses this way. And that means I've got now 5 times 4 plus 3 plus 2. And so again, that was the associative of addition property. And now let me try my commutative property. It's a totally legal move because it's all within parentheses. I'm not ripping it out like that. That would be illegal. You cannot do that move in math class, but you can totally change them around within parentheses. So then we're going to go 4 times 5 plus 3. This is the commutative of multiplication plus 2. Did that work? Everything seemed to check out? Yes. So that one worked. Let's try the other way and see if that would work as well. And see if we commit any illegal math move. So I'm going to write down what we started with, 5 times 4 plus the quantity of 3 plus 2. And this time I'm going to do the commutative property first. So I'm going to do commutative of multiplication. I'm going to change those two. So then I've got 4 times 5 plus the quantity of 3 plus 2. And now I'm going to do the associative of addition property. And I'm going to move my parentheses this way. And then that means I'm going to do 4 times 5 plus 3 n quantity plus 2. And then let me check, make sure my brain's not farting out here and that I didn't make a mistake. So here is exactly what we ended up with. Was this also okay? Did we make any illegal math moves? And the answer is yes, it's okay. No, we didn't make any illegal math moves. So in this case, this is one of your 2. I gave you half of it. One of your 2 that can be either order. So you should be highlighting the E on that last column for number 19. So this one can be either order. So now you have one more that is going to be either order. All right. So now we are going to go back to our notes. And we are going to finish up with this one. And let me back up for a second. I do not, on this page, I do not require you to write it all out like I was doing in this. Like I don't require you to do that. I personally, if I was you, I would have out a scratch sheet of paper and I'd be working through it like this. So I would make sure I'm not making a brain mistake when I'm trying to move things around. It's because it's easier for me to do on paper. If you can write out like the little arrows and kind of do some things on your actual notes, like right in here, how I was doing it here, and you have space to do that level of show your work, that's fine. So if you can kind of be like, oh, parentheses moved, and then I've got terms that are moving, that's okay for me for this page. However, when we get to this page, you are writing them out like what we were doing, like I was showing you on that other document, on that OneNote document, kind of my scratch page that I was using. So I'm going to show you some examples here so you know what to expect. The directions up here, it says identify whether the property used to rearrange the equation was the associative, commutative, or distributive property. If it was the associative or commutative property, specify whether it was of multiplication or addition. So these, you've gotten to do so much practice on them on the previous pages, you're probably going to do just fine. But you're looking at how did this compare to here? And I'm hoping you're saying, oh, these 2 traded places. That's the commutative property. What operation did it trade across? It traded across addition. So that's going to be the commutative property of addition. And that's what you're going to do. So that's what I require you to do for this one. So like you're showing the arrows, you're writing out, that should be a plus sign. It kind of looks like a weird letter. It should be a plus sign. So that's what I require you to do for these. So like this one, how does this compare to here? It looks like the distributive property. So that because it's negative x and now it's positive 3, so that's the distributive property. Our next one, we've got 7, 25, and 4. 7, 25, and 4. The parentheses, they moved this way. That is the associative of multiplication property. And so that's what I want you guys to do for 1 through 9. Now let's come down here. This is one of, again, a portion of this video that you might need to practice lots of different times. You might need to watch it a couple times. I've encouraged students in the past to print this particular page out several times so that you can do it once with me on the video, and then you are going to practice these again on your own and see if you can do it without any help from your notes that you've already filled in, and see how you do on that. So here's what I have you do. It says show each step and identify which of the associative, commutative, and distributive properties were used in the problem. You also have to specify whether it was of multiplication or addition if we're using the associative or commutative properties. And a problem may use, and almost all of them do, will use more than one property. And sometimes the order matters and sometimes it doesn't. But we are becoming the associative, commutative, and distributive property gurus now. So we should do okay. All right, so let's look at the first one. Let's see if we can just kind of jot down ideas about what we see happened. So here what I see is that for sure the distributive property was used, because if I distribute here, I'm going to get 10 minus 5a. And then once I get 10 minus 5a, they're going to need a flip order. So that means the distributive property was used, and then flipping the order, that's the commutative property. And then we can see whether it's of addition or multiplication. So here's how I have you guys write this out. It's almost like a proof. So we're going to take this left-hand side and we're going to write 5 times 2 minus a. This is your given. That's what you're starting with. Like I said, it's kind of like a proof, a line-by-line proof. Now you're going to show your work. We're going to distribute. And this is going to give us our distributive property. So below it, you can write distributive property took place, which is going to give us 10 minus 5a. And now, like you're looking again, how do we get from this step to here? We need to trade places. So these are going to trade places. What property is that? What property occurred? The commutative of addition property. And I know some of you might be like, wait, that's subtraction. Well, don't forget, we can rewrite it like this. We can go 10 plus a negative 5a. And so then you're taking 10 and negative 5a and you're flipping it across that addition sign. So then we're going to have negative 5a plus 10. Done. We did that right. So then that's going to be distributive. And then we did commutative of addition. All right, let's try another one. I'm just going to jump over to 13 because it's at the same kind of horizontal level. All right, so it looks like, again, we did distributive and some terms changed places as well. So I see that the 3p minus 3, I'm going to get that if I distribute here. And then 2 is at the beginning here, but it's at the end over here. So here, I'm going to show you two different ways on this one. I'm going to give you the more efficient way first. The more efficient way is, let's go ahead and start with our given. So we're going to write 2 plus 3 times p minus 1, and this is given. This is what we're starting with. And I'm going to take this chunk and this 2, and I'm going to trade places because we can totally do that. We're taking that entire quantity and the 2, and we're trading places across that addition sign. And so that is going to be the commutative of addition. And then we are going to get 3 times the quantity of p minus 1 plus 2. And then what we are going to do is we're going to do the distributive property. We're going to distribute. So then we get 3p minus 3 plus 2. And that is your, don't forget to write in your D because I forgot to write mine in. That's your distributed property. And then you look, check, this looks the same as up here. We're done. Well, here's your other way you could have done it. So you'd still start with your given. So I'm still saying, let's pretend like we wrote the given statement. Let's pretend we did the distributive property first. So we've got our 2 plus 3 times p minus 1, and that's given. Let's say we distributed first. So we did the distributive property. And then we're going to have 2 plus 3p minus 3. And now we've got to get the 2 all the way at the end. But you can't just like move it to over. We got to move it one space at a time. So we're going to have commutative of addition. So we would have 3p plus 2 minus 3. And then we've got to do it again. Move those 2. So that's a commutative of addition again. So then we would get 3p minus 3 plus 2. Boom. We're done. That's the final answer. Right at the end. Okay, let's try another one. Let's look at this one. And again, you should pause this video. Like if you haven't already, I'd pause it. Try to do these on your own and see how you do. And then come back. If you get stuck, come back and watch me go through it. All right. I see that 24 and A are grouped together. And I see that 3 has totally moved places. And so moving means commutative. Grouping means associative. We only have multiplication, so both these are going to be multiplication. Here's the other telltale sign, because it's going to matter what order we do it in for this one. I see that 24 and A, they go 24 and then A. And that's exactly the order that they're here, 24 and then A. So that tells me that I should move my parentheses first. So let's move. Well, and hang on, I got to write my given statement first. Here we go. Got to get my first point for my problem. 24 times the quantity of A times 3. This is our given statement. Now what I would like for you to do is to move the parentheses to the left. Then you're going to get 24A times 3. How does that compare to here? How it compares is that the 3 and the 24A changed places. And so the other thing I forgot to write up here, by the way, was my associative of multiplication. So now I'm going to do my commutative of multiplication, and I'm going to get 3 times the quantity of 24A. And that is commutative of multiplication. So one thing I want to point out is that this is the one. This is the problem that I've seen so many times students try to like pull a number out of its grouping. So they'll go like, they'll start with this. They'll go 24 times A times 3. And then they're like, oh, I'm going to pull that out. And that's commutative. So then I'm going to get 24A times 3. And then they move the parentheses over and they'll do something like that. This move, you doing this right here, that is illegal math move. You can't do that. So don't be tempted to do that. If you find that you have to do that to make it work, that means there's another way to go about the problem. All right, let's look at the next one. The next one, if we're looking at how we've got 3t and we've got 3t here, and we've got 4 times 15 and 4 times 15. And guess what? We have 4 times 15 here as well. This is starting to look like distributive property to me because we've got 4 times 15 in both places. And it's times first the 3t and then times second the negative 2. So I think that's exactly what happened. So we took this and they distributed it first to the 3t and then to the negative 2. So I'm going to write up and I'm going to say 3t minus 2 times 4 times 15. This is given. Now I'm going to show my distributive arrows. I'm going to write in distributive property, or you can just write a D. And then it's going to be 3t times 4 times 15 minus, this is a minus, 2 times 4 times 15. And that's it. We already got to the answer on that one. That one is pretty easy. All right, number 12. Number 12, you can do lots of different ways. So I'm hoping you see that the 2 and the X and the 3 and the Y have traded places. And not only have they traded places there, but within the terms, they've traded places. So the traded places, that's commutative of addition was the first one. And then commutative of multiplication was the other one. This is one, it does not matter the order. If you want, you can do commutative of multiplication first and then commutative of addition. Your choice. So you pick which way you want to do it, and I'm just going to write up mine. So I'm going to write y3 plus x2, and this is my given. I don't know. I'm going to take care of my commutative of multiplication first. So I'm going to take care of these two. So I'm going to do commutative of multiplication. And that's going to give me 3y plus 2x. And then, and if you want, what you can do here, you can say, well, you can even put the commutative multiplication right there. And then what's going to happen? We are going to take these two and trade places, and that is the commutative addition property. And that gets us to 2x plus 3y. Boom, there's our answer. All right, the page, or sorry, number 15 on page 99. And again, your page number might be different. That's okay. This problem is probably the trickiest of all. And so pause the video again, see if you can figure it out, because I've had students figure this out. It takes a little bit of time, but you guys have it within you to do this problem. So try it. That's all I want you to do. Try it and see how you do. And before you even start moving things around, like make a list off to the side of like things you notice. What moved, what traded places, how did the parentheses change if they changed? So let's look at that. Okay, so one thing I'm noticing is that 3 changed all the way from the front to the back. But then check this out. We've got P4QR, P4QR. That is fantastic. So all of those stay the same in order. So that means the only thing that changed was this 3. So we've got commutative of addition because it's going to trade place over this addition sign. And then we've got associative. So we've got associative, and it looks like here the 4 and the Q are together, but here the Q and the R are together. So that's associative of multiplication. And then here we've got the 3 and the P are together, and over here the P plus 4QR are together. And so that's associative of addition. So here again, don't be tempted to rip 3 out of its parentheses and move it first. So what I'm going to tell you is that we're going to have to do associative property first, and let's see how we can get there. Or if you already see how you can get there, pause the video and do it, and then check it to make sure you're right. All right, so I'm going to start with what's given, and I'm going to have 3 plus P plus the quantity of 4QR, and this is given. And then I'm going to move some parentheses because I know I can't move 3 until I get it out of its grouping. So I'm going to move my parentheses over, and this is going to be my associative of addition when I get ready to do this. And so I'm going to have the 3, and I'm going to have the parentheses of P plus parentheses 4QR and parentheses. All right, so essentially what I have is I just put this together, right? So now let's compare what I have to what I'm ending up with. So one thing I'm still noticing is these parentheses changed. So let's take care of that. That looks easy enough. So I'm going to do parentheses again are moving this way, but in this time it's going to be the associative of multiplication. And so I'm going to do that first. And I want to back up and say one thing. If you happen to do associative of multiplication first on this step, totally fine. That would be totally okay to do that. So it's okay to switch the 2 associative properties in their order. So that would have been all right. All right, so let me write it with the new parentheses moved around. So we've got P plus 4 and then the Q and the R together. All right, so my last thing, I am going to take 3 and this entire mess of a quantity, and they're going to trade places. And that, my friends, is going to be the commutative of addition property. And then we're going to get quantity of P plus 4 times the quantity of QR plus 3. And then look, is that what we ended up with? Yeah, we're done. That was a big problem. Good job. All right, a couple more back here, and then we're done with this video. All right, so the directions at the top, it says use one or more of the properties to solve the problems as efficiently as possible. So we are specifically wanting you to use the commutative property, the associative property, something here to help make these problems easier to do mentally. math. So for example, on this one, I see common denominator, common denominator. So let's move these two. So let's do the commutative of addition property. And then I'm going to get 3/4 plus 7/4 minus 5/2. So then I'm going to get 10/4 minus 5/2. And guess what? That's going to equal, because this is going to reduce to 5/2. 5/2 minus 5/2 is a whopping 0. Perfect. Let's check 19. 19. So this one, you get to put some parentheses in because the order doesn't matter. These guys are already right next to each other. And why is that helpful? Because they're reciprocals of one another. But order of operations would tell us to go from left to right. It would say do 16/9 times 5/3 times 3/5. But you know what? We're smarter than order of operations, and we're going to put parentheses around that. And we are going to say, well, 5/3 times 3/5, that's going to be 15/15. Or you can recognize that they're reciprocals of one another and they would reduce to 1. And so my answer is just going to be 16/9 for that. So that's what you're supposed to do for the next few. Like you're going to need to put parentheses in on one more, and then another one you need to move them around. And then you can finish answering the questions down here, 20 through 24. And that is it. Thanks so much for tuning in, and please reach out if you have any follow-up questions.